Exercise 5A, exponential functions. In this exercise, we are learning about the graphs of exponential functions. What you need to be able to do is find the horizontal asymptote of an exponential function, apply transformations, find intercepts, and sketch exponential functions over a given domain. So this is the graph of an exponential function. You would have learnt about this in year 11. You can see that it increases as x increases in an exponential manner. This line here is a special feature of exponential functions, which is what we call an asymptote. So that means that the graph is going to approach this value, but it'll never touch it. So just in our normal y equals a to the power of x graph, that asymptote is going to be at y is equal to 0. It will never be able to reach this value because there's nothing that we can ever make equal to 0, or there's no value of x for which putting it to the power of will be equal to 0. So that's why it's an asymptote. This is the general function of it. So y equals a to the power of x minus h plus k. H and k are just your left and right translations. A is going to be a base, and that'll determine how fast or slow the graph is going to grow. The key thing to know is your asymptote, which is y equals k. That is going to determine where your graph is going to sit. So let's start by sketching some of the following graphs. So the first one is going to be y is equal to, or rather f of x is equal to 2 to the power of negative x. So keeping in mind that this is our normal graph, if we were to think about it as 2 to the power of x, then all of these negatives here are going to result in reflections. And coming off of our transformations functions chapter, hopefully that will be quite easy to recognize. So for part A, we'll start by drawing up an axis, and we can recognize that this negative over here is going to be a reflection in the y-axis because it's attached to the x. So normally my graph is going to do this. Now it's going to go in the opposite direction. We have a move left or right, so our asymptote is going to remain at y equals to 0. We probably should draw a straighter line. Let me try that again. So we'll just kind of put it a little bit off the axis so we can clearly see it. So that's at y is equal to 0. And as we said, we've got a reflection in the y-axis, so it'll climb up like that. Now, if we make x equal to 0, we can see that y is going to equal to 1. Anything to the power of 0 is just 1. And in fact, every exponential graph, given that there's no transformations, will have an intercept at 0 and 1. Okay, so now if we were to do part B, so same idea, y equals negative 2x, so the negative in the front implies a reflection in the x-axis this time. Everything else stays the same. So once again, I'm going to put in my asymptote. That'll be at y is equal to 0. And this time, it's going to be reflected in the x-axis. So it'll go downwards like this. Now, usually our intercept is at 0, 1. Because there's a reflection, it'll now be at 0 and negative 1. For part C, very similar idea. We can see that we've got two negatives this time, one on the outside and one on the inside, which would imply both a reflection in the x and the y-axis. Okay, so this is my normal graph. This is reflected in the y, and that would be reflected in the x. Because there's no other transformations or anything going on, our y-intercept will be at 0 and 1 as well. Okay, so that's how reflections will affect the exponential graphs. Now we will try some with more transformations. So this one says, sketch the following graphs showing intercepts and asymptotes stating the domain and the range. So there's a few things we need to do. We need to sketch, we need to make sure that we're showing intercepts and asymptotes, and we need to also state the domain and the range. Okay, so we'll start with part A, that should say A. So this is very similar to a graph that we just drew, 2 to the power of negative x, which remember is a reflection in the y-axis. However, what's happening this time is that we are going up by 1. So our asymptote is now going to be at y is equal to 1 rather than at y is equal to 0. So that should be there. We can label that as y is equal to 1. And we've also got the reflection in the y-axis. So it should look like this. Now, in terms of our intercept, Before it was at 0, 1, and then all that's happened is we've moved up. So that should be at 0, 2. But to confirm, we can also just make x equal to 0, just to make sure. So 2 to the power of 0 is just 1. 1 plus 1 is equal to 2. So that's confirmed that that is correct. There's no x-intercept there that we need to write down. We're also going to state the domain and the range. So for the domain, we can see that it's every real value. And for the range, we can see that that's from 1 to infinity, but we don't include 1 because at 1, there is an asymptote. Okay, for part B, it's very similar. We've now got a reflection in the y and the x-axis, and we've also moved downwards by 1. So this downwards by 1 is going to determine where my asymptote is going to be at. So my asymptote is at y is equal to -1 this time. Make sure you label that asymptote. In terms of my reflections, so this is my normal graph. This is reflected in the y, and then this is reflected in the x like that. Now, in terms of where it's going to sit, when you draw a graph like this, I would always suggest that you find the x and the y-intercepts before you draw it in, because you don't know if it's going to do that. It's going to pass through the origin, or if it's going to go upwards. We can estimate because, usually the intercept is at 1, and then if we go down by 1, it should be at 0. So for this particular graph, we can figure out that it's there. But I wouldn't take that chances with other graphs. So sometimes it's just better to find the intercepts first than to put it in. Now, in this case, because it's a reflection, it's just going to be down here. When it's reflected, it's at 0, -1. Because we've gone down by 1, we can assume that it's going to be at 0, -2. However, it is best to check. So once again, so that should just be -1 minus another 1, and that'll be at -2. Okay, now I just want to check that I've done that sketch correctly. So that's like that. Normal graph, reflection in the x, or the y, and then reflection in the x. Perfect. So that is the correct direction there. All right, example 3 says, oh, sorry, actually, we forgot the domain and the range. It's very easy to keep moving. That's why I try to highlight it, even then I forgot again. So the domain is just r. The range, I can see the smallest number is -infinity, and that goes till -1, not including. Okay, let's have a look at example 3. It says sketch the graph showing the intercepts and asymptotes, stating the domain and the range. So the same idea. There's a little bit more going on here. So first of all, we can see that we've gone to the right by 1, which isn't going to make a huge difference in terms of what the graph's going to look like, but it will of course affect your intercepts. And we've also gone down by 2. So what I might do is before I go ahead and sketch, I might actually find my intercepts so I can make sure that I've situated everything incorrectly. So we'll start off with the x-intercept. Sorry, it's a random search bar that's just popped up. So we'll start off with the x-intercept. So that means we'll make y equal to 0. Okay, take the 2 over. Now, because the bases are the same, we can actually just equate the powers. Therefore, x will equal to 2. So that is going to be our x-intercept there. For the y-intercept, we'll make x equal to 0. So that will just be y is equal to 2, 0 minus 1 minus 2. So that's just 2 to the power of -1, which is actually a half, and then 2 minus a half will be -3 on 2. So that will be my y-intercept. Okay, so I'm going to go ahead and sketch my graph now. It's a little bit tight, might make myself a bit more space. All right, so that's x, y. Now the asymptote is always going to be this value over here. It's gone down by 2. So that'll be y is equal to 2. Sorry, -2. And then we can go ahead and put in our intercepts. So we would have 1 at 2, and the y-intercept would be at -3 on 2. Then we will draw in our exponential graph to look something like this. 2, 0, 0, -3 on 2. Okay, in terms of the domain, once again, I can see that it's all real values. However, the range, the smallest y value that I can see is -2. and that will go all the way till infinity. Okay, next example. Once again, we've got these two. Sketch the graph showing intercepts and asymptotes, stating the domain and the range, show all workings, and then the second one is with a CAS calculator. So we'll do it by hand, and then we'll just quickly go over how to do this on the CAS. But it's very much the same idea. You might want to pause the video and give this a shot yourself. So once again, we're going to start off with the intercepts. We'll go for the x-intercept. So that's making y equal to 0. We'll take this over. Now, we haven't quite learnt this year. Hopefully you do remember it from last year, but when it's a different base, the way you take it over is you take the log of both sides. So that will become log 3, 2, and that will be a 1. Doesn't necessarily help us to figure out if that's a negative or a positive number, but I mean, everything's positive there, so it's probably a positive number. But we'll work on that a little bit further down the track as well to be able to work out your logs. All right, looking at the y-intercept, so we'll make x equal to 0. So that's 2 minus a third. So that will be 5 on 3. Right. In terms of any other transformations that has happened, we can see that there is a negative here. So that negative is going to be a reflection in the x-axis. So just keep that in mind when you're drawing. And of course, one of our key points is that our asymptote is going to be at y equals 2. So I might just quickly write that down. So we've got a reflection in the x-axis. And then because we've gone up by 2, it means that we've got an asymptote at y is equal to 2. All right, let's go ahead and draw up a nice set of axes. We'll put in our asymptote. So our asymptote is going to be at 2. And then we will ensure that there is a reflection in the x-axis, and we know that our y-intercept is positive, and we've assumed that our x-intercept will likewise then be positive as well. So it should look something like this. Let me try that again. I just want to point out here, see how the graph is going away from the asymptote? You'll actually lose a mark for that. So graphs should always approach the asymptote and never move away from it. So sometimes it just takes a couple of times to try that, and especially when I'm hoping that my graph will just click into the right place. Likewise, your graph should never touch the asymptote, so that likewise would not get a mark there. Okay, so my graph is now approaching the asymptote, but not touching it. That is correct. So 0, 5 on 3, and then this one is log 3, 2 plus 1, and 0. Now the domain for this function is R, and the range, the highest y value I can see, or the lowest, sorry, is negative infinity to 2. And I've just noticed I've not labeled my asymptote, which you would also lose a mark for. Okay, so this is what your graph should look like. You should also label the axes. Now, in regards to putting that onto the CAS calculator, so my CAS just looks slightly different to yours on the iPad, but it's still the same idea. Actually, I should open up a graph page. So we can just type that in. So 2 minus, and it's 3 to the power of x minus 1. Press enter, and you'll see it looks like that. What you will notice though, however, is that there's no asymptotes that are showing. So you kind of just need to figure it out. It's implied. You can do a graph trace. And then if you can see the coordinates here on the right-hand side, it's approaching. It actually says 2. It should never be 2. I think it's just that the decimal point is so close to 2 that it says that, but it should never actually be 2. But you'll notice that it'll never go above. In terms of finding the intercepts, so if I go over here, I can see that it's 1.67. However, we should always state our values with exact values. So to do that, you would usually do that through your calculator page. So if you go to your calculator page, we've now written that as f1 of x. So I can do f1 of 0 as 5 on 3. You can see that's given me in exact values. And then to find the x-intercept in exact values, we can go to algebra solve. We want to solve f1 of x is equal to 0. Enter. Thought I wrote X. There you go. It's given you a different log. That's log E6, which we haven't learned yet, the natural log. But it's still, I suppose, an acceptable form. It's probably not as good as the one that we've written or figured out by hand, but that just shows you that the calculator is limited in one way or